Welcome to everyone for the session on geospatial literacy for space, Earth observation, and education. This is going to prove to be an incredible learning experience as we have the opportunity to hear from leaders in the field of geospatial applications and education. Not only do we get a peek at the latest and greatest work that is occurring to help us better understand our world, we're hearing about the requirements behind that work. So what makes it a success? This is where geospatial literacy and education is key. In the panel following the presentations, we'll have a chance to discuss the critical importance of geospatial technologies and literacy and how this is really a fundamental literacy in the 21st century. Ultimately, the goal of this session is to discuss, develop, and champion the cause of geospatial literacy and education in the workplace, in society, and find ways that educators, geographers, geospatial professionals, and others can work together collaboratively to develop a common vision for a geospatially literate society. And the collaboration starts here. This session was initiated and sponsored by the Royal Canadian Geographical Society and the educational arm of that group, the Canadian Geographic Education, which consists of over 26,000 educators in the country. And of course, Geoignite. With our champions, Peggy March, the 2019 recipient of the Canadian Geospatial Community Leadership Award, and RCGS Fellow, who's been doing a lot of the work behind the scenes, so thank you, Peggy, and Paul Van Zandt, RCGS Fellow and Chair of Canadian Geographic Education, again doing a lot of the work behind the scenes. You won't see them, but boy, their presence is felt here. Thanks so much to John and Tessa of Geoignite as well for the opportunity to have this session. My name is Lynn Moorman. I'm a professor of Earth and Environmental Science, Geography, Geospatial Technologies, Physical Geography at Mount Royal University in Calgary, Alberta. I've worked with Canadian Geographic Education for over 12 years now, and I'm a governor of the Royal Canadian Geographical Society. I'll be facilitating the summit today, as well as our panel discussion, starting in about 2 hours from now. During that panel discussion, there's probably going to be more time to ask questions. This session today, it's going to be quick. It's full of information. You can ask questions in chat, but we won't have a lot of live time for questions. So, just be prepared for a lot of great information coming your way today. I'd like to introduce Gordon Osinski to give our keynote address, speaking of some amazing information. Oz is a geologist. He's a professor in the Department of Earth Sciences at the University of Western Ontario, where he's also the director of the Institute for Earth and Space Exploration. This work has allowed him to conduct fieldwork on 5 continents, including Antarctica, Australasia, Africa. But the Canadian Arctic is where much of his work is taking place. It was largely in recognition of the scientific exploration in the Canadian Arctic and his work there that he was elected a fellow of the Royal Canadian Geographical Society. He's engaged in developing technologies and techniques to better enable the exploration of remote regions of Earth and space. And in that context, he's involved in providing geology training to Canadian and US astronauts. He's absolutely passionate about outreach and science communication. He leads several initiatives, including Space Matters and Impact Earth. Dr. Osinski, welcome to our session. Thank you very much for contributing our keynote address, and I will welcome you to start Perspectives, the Power of Geospatial Literacy for Space, Earth Observation and Education.
Oh, thank you, Lynn, for that wonderful introduction, and it's an absolute honor to be here today. So let me get the ball rolling here and share my presentation. Okay, so hopefully everybody can see my PowerPoint slides. Yeah, so it's I basically titled my presentation like the title of this session, The Power of Geospatial Literacy for Space, Earth Observation and Education. And what I'm going to try and do today is actually give a bit of an introduction and an overview, for some of you out there listening, just what is geospatial data, why geospatial literacy is important, and to touch on the 3 major kind of aspects of the title, which is space, Earth observation, and education, which, as Lynn mentioned, are kind of 3 things that I do and that I'm very passionate about. So in the interest of time, we'll just jump right into things. So, what is geospatial data? That's perhaps something that we should think about initially. You can put the terms into your favorite search engine and come up with quite a few different definitions, but definitely with a lot of commonalities. It's data with a geographic component to it, data that's indicating or tied to a particular geographic location, or a term used to describe any data related to containing information about a specific location on the Earth's surface. And hopefully what I'll show you today and others too, that we're not just restricted to the Earth's surface when we think of geospatial data. We can get geospatial data, going back decades from global positioning systems, of course, satellite images, and a revolution of the last decade or so is the smartphone. In the hands of many people on this planet is the ability to geotag and to provide geospatial data, not just for themselves but to others. And a lot of the talks today that you'll hear from others will touch on that as well. When we think about geospatial data, we also think of it in terms of two main types. Vector data, which could just be a simple point on the surface of the Earth or another planet, or polygons and lines and shapes, or what we call raster data. This is a digital elevation model, or it could be a satellite image. So it comes in all shapes and forms. I also thought it'd be kind of fun at the beginning of this presentation and the session to just delve back in history a bit. I know when I was an undergrad, the word geospatial wasn't used too much. People have actually done word searches and studies, and it was really only introduced in the 1980s, picked up in the 1990s and the 2000s. But of course, we have been using and producing geospatial data for millennia. So the word may be slightly newer, but the concept certainly isn't. And, we can go back many millennia, and, a way that we have shared geospatial data, presented geospatial for millennia as maps. And, as an explorer, as a geologist, I use maps all the time. And this is an example of the Babylonian city of Nippur from 1400 BC. I came across this, very interesting example where, we started to kind of blend scientific knowledge with mapping or other types of scientific knowledge in data sets. This is probably quite timely in these COVID days that we live in. This is a map from 1848 by a British physician living in London, and he mapped out house by house where cholera had been reported during that epidemic. And so this is an amazing geospatial data set presented in map form. Of course, the space age kicked off another realm of the availability of geospatial data. And, Landsat-1, this first ever image sent back of Dallas in Texas in 1975, really was a turning point in the availability of data from space in terms of geospatial data. I think we have to acknowledge too, putting then that data in the hands of all of us and everyone on this planet who has, the technology, Google Earth, who hasn't sat there looking at Google Earth, kind of wandering around, not just your neighborhood, but looking around our planet with Google Earth. And of course, our next speaker, Tanya, I'm not sure she's going to talk too much about her day job at Planet in her presentation, but through the likes of Planet and other companies now, we have this mind-boggling and amazing capability to image every square meter of this planet every day. And so, we're awash with geospatial data. And I think a question that a lot of speakers will touch on today is, are we actually more geospatially literate or not because of all of this data? And that's a discussion that maybe we can continue at the panel discussion. I did want to throw in this too, just to kind of emphasize again, not to belabor the point too much, the power of maps. And again, this is a very out of date map because it's from last year from the COVID epidemic, but by presenting geospatial data in a map format and through using geographic information systems, it really, I think, enables people to better visualize abstract and a very complex data sets in a more easily representative form. And this, of course, was actually put together and is from the Canadian Geographic website. I'm excited about an upcoming presentation in the session by Trevor, who will talk about the smart ice presentation, which is another great example of of geospatial data and involving northern communities. Education. So education is part of the title of this session too, and I think a lot of our speakers will be highlighting various different aspects of, how we can either use geospatial data in education, in our education systems, and how important geoliteracy is. And I'm looking forward to these talks. Lynn mentioned at the beginning my role in Space Matters, and so I did want to take a couple of minutes to showcase this education and outreach initiative that we launched a couple of years ago that we're trying to reinvigorate. And so if there's any of you on the call who are interested in participating and joining this initiative, please let me know. And so really the initial goal of Space Matters, and the major goal, and I don't expect you to read word for word here, is to raise the importance of space to Canadians. And, of course, a big aspect and why I think, space should be important to Canadians is how it pervades, almost every aspect of our daily lives. And a lot of that is due to satellites that are orbiting our heads right now. They're enabling us, to have this virtual conference today. If you did a banking transition today, it enabled that. And of course, the use of satellites for monitoring climate change and smart agriculture is really revolutionizing how we live. And of course, exploring space is still a big part of what we do as Canadians as well. And so a big goal of Space Matters is to bring together educators and to provide workshops and resources. And I'll showcase one of those in a second about how, how we can teach children and youth about what satellites are and what they can be used for. So space is also in the title of the conference today. Many people think that space exploration and Earth observation and looking after our planet are disconnected, but I actually completely disagree with that. And I think we're doing both, and we can do both very well as a country and as a species. I really like this. This is one of my favorite all-time graphics produced by the European Space Agency. And it's about exploration. It's about where we've been and where we're going in the future. And it's about how intricately linked exploration, geospatial data, and geoliteracy is. It's always, I could spend way too long in this image, and I won't. But this really emphasizes, 100 years ago, the likes of Shackleton and Scott were major names in exploration, and they were exploring the harsh regions of our planet in sailing ships, just over a century ago. We then took to the skies in the early part of the last century, and then in the mid part of the last century, to space. And we're seeing a revolution in the exploration of space, which we'll see astronauts returning to the moon in the next couple of years, which, for someone who was born after Apollo, I cannot wait for. I've been waiting for it, I think, my entire life, and it's going to really, I think, revolutionize and excite our whole country and the whole planet to be more engaged in exploration and in geoliteracy. We do have a proud heritage, of course, in space, and I can't talk about space without emphasizing the fact that, Canada was the third country in space. It was only actually until I worked at the Canadian Space Agency, I'm embarrassed to say, that I learned that fact. And I think many kids across Canada, many schools, you don't learn that. And so after Russia and the US, Canada was the third country in space after the launch of the Alouette 1 satellite in 1962. That to me is a fact that every Canadian should know. Of course, Alouette 1 and many of the earlier satellites and many of the satellites today are looking down on our planet or studying the atmosphere and the ionosphere, providing really critical information about the health of our planet. As we look to the future, we're not going to stop that. We're going to keep doing that. But again, these are really exciting times where, we're going to have astronauts returning to the surface of the moon. And if you listen to the news last November or December, I forget exactly when, the Canadian government announced that on the first mission back to the moon since Apollo, this will be an orbiting mission. There'll be a Canadian astronaut. We don't know who yet. I'm sure there's 4 of them to choose from, but we'll have that perspective of looking back at the Earth from the moon again in high resolution and in high definition. And so that's kind of something else I wanted to touch on too. And it was in the news last week we just celebrated Earth Day, and it is not a coincidence that the first ever Earth Day in 1970 took place, not long after the humans first landed on the moon, and the year before. And, it is these iconic images from space and from the moon that, really emphasize that we live on one single planet. It's a very delicate pale blue dot, to use the language of Carl Sagan, out there in space. And again, it's really interesting if you listen to the testimonials and what the astronauts spoke to. We'll hear about, astronauts in the space station later on today too. I think all of them come back very humbled and appreciative of the planet that we live on. Alan Shepard, always a very stoic man, according to the literature. When I first looked back at the Earth standing on the moon, I cried. I think Bill Anders also summed it up very nicely. We came all this way to explore the moon, and the most important thing is that we discovered the Earth. And so I do think by exploring space, by going back to the moon, it does deepen our appreciation of the planet that we live on and how we do need to protect it. We're of course going to hear from Dave McLean later on about how the International Space Station has been an amazing outpost. So continuously since the year 2000s, we've had humans orbiting above us, which is a simply amazing fact in its own right. But they do offer a unique perspective that is different from satellites. They can capture things just as they're happening. Amazing volcanic eruptions or hurricanes happening. And of course, having a human hold that camera is very different, and the ability to react in near time. So I won't steal Dave's thunder, because he'll be talking about this a lot more later on. I did want to emphasize another initiative that I was happy to be part of, the Exploring Earth initiative. And this was actually put together in conjunction with the Canadian Space Agency, Ingenium, and Canadian Geographic Education during David St. Jacques' mission a couple of years ago. And this took images that David St. Jacques took from space and other astronauts, plots them on the Earth in a geospatial reference format, and then you can learn about various different things, from mountains and volcanoes to the different biomes on Earth. And in this particular example here that I randomly chose, peatlands in Australia. So back to Space Matters. Again, just kind of quickly, if there are any educators out there, one of the activities that we do in Space Matters is we have an activity that you can download, teaches children about satellites. What is a satellite, how we can define it. And then, more importantly, I think, why do we need satellites? And again, this is a general theme of Space Matters about how important space is. We may not think about it every day, but it really is important for our everyday lives. So, from communication and navigation to weather, climate, and natural disasters, and to smart agriculture. And, one of the things, the activities that we do is a change detection exercise. Although, for kids, spot the difference, right? Who hasn't played this activity, done it yourselves when you were younger, or have kids where there's two images, and it takes some time for you to to look in, say, okay, there's an extra cloud here blocking the sun, or look, there's an extra window there, and that kind of thing. Well, you can do this with satellites, of course. Today, you can do it for yourself on Google Earth through the historical imagery that they provide. But in this activity, we provide very key examples, images of the same place on Earth, or Landsat imagery, and get people to really think about what has changed and why things have changed. A dramatic example is the Aral Sea in Kazakhstan. Once the world's fourth largest lake, reduced to 90% of its extent in a little over a couple of decades. Another example is here, the Amazonian rainforests. We get the participants to describe what you see, what are the differences between these images. And so you have to start basics. This is forest cover. What are these lines appearing over here? Well, this is actually, roads and streets and buildings. But again, like it or not, the satellite imagery does really emphasize how much and we get into this in the kind of third point, as humans are changing the surface of our planet, in this case, absolutely dramatically. a lot of what I do is not just Earth observation, but it's exploring the moon and Mars. And a lot of what takes me up to the Arctic is actually looking at what happens when asteroids and comets strike the Earth. And so, with the use of satellites for space exploration, of course, has been there since the very beginning. And most of how we explore the solar system and how we ever will explore the solar system and the universe, because it's so big, is not through humans or even rovers and robots on the surface of planets, but through satellites. And so the Impact Earth initiative that Lynn mentioned is something I'm quite proud of. And this is where it is a geospatial initiative that we've been working on for a number of years now. And if you go to this website, the core of it is, and you can follow us on Twitter too, quick plug, impact_creators. You can go to the website, impactearth.com, and the core of it is a geospatial database that is interactive and that you can search through to find out all the locations of meteorite impact craters on Earth. You can search by size, where they occur on the planet, if you're interested in certain diameter ranges. We have activities for teachers as well, rock kits that we can actually loan out. And so it's a great initiative. I would love if, you can go and check this out afterwards. But again, it's really possible because of the geospatial data that we have for these various locations and these various impact craters on Earth. What brought me to Canada is the fact that Canada has so many impact craters. So I came over for my PhD in the late 1990s to study this particular crater up on Devon Island. If I had more time and if I was in there in person, we could do a bit of a pop quiz about whether these iconic sites are in Canada. But I'll leave this up if you're kind of watching this after the fact. We have the Precambrian crater in northern Quebec, 3.5 kilometers across. The Horton crater, very well preserved on Devon Island in the polar desert. The twin west and east Clearwater Lake structures, and Manicouagan in Quebec. If you browse, Google Earth, many of the Canadian craters are actually visible from space, unlike many other parts of our planet. I've also, of course, been on to a lot of these craters on the ground, and as a geologist, a lot of what I do is field geology, going out there to conduct mapping, to learn about these environments and collect samples to bring back. Just very quickly, this is the Mustaching crater in Labrador. This is a really amazing site that's going to see a lot of renewed interest, because it's actually an excellent analog site for the moon, because the target rocks, the rocks that were impacted up there in northern Labrador, are mainly anorthosite, which is essentially the lunar highlands, the bright white rocks on the surface of the moon. And here we have a crater formed in this that is well preserved, and you can see columnar joints, so cooling joints in this melt rock. This is essentially lava produced by this impact event about 30 million or so years ago. West Clearwater Lakes and East Clearwater Lakes up in northern Quebec, just huge, vast areas, big cliffs. You can see building-sized blocks suspended up in these melt rocks. And the other fascinating thing, the thing that I enjoy about a lot of Canadian craters is that they haven't been visited since the 1960s and 70s. And so there is a true aspect of exploration here, going to some of these sites, sometimes for the first time in terms of newly discovered sites, or sometimes not since the 1960s and 70s. And so there is a bit of a blank slate and so much work to be done in a lot of these locations that is blending exploration, geographic and geological data with the spirit of exploration. Some of these sites are, as you go further north, these are two images from, and the zoom background behind me, in case you were wondering, is from the Horton impact crater on Devon Island in the Canadian high Arctic. So, Devon Island itself is just an amazing place, the largest uninhabited island on Earth. It's where I did my PhD. It's the size of Nova Scotia. We're not talking about a very small place here. It is over 60,000 square kilometers with not a single permanent inhabitant. Hardly any vegetation to speak of, very unspoiled, and it makes it an excellent analog environment for other planets. And so that's kind of something that I just wanted to wrap up the talk, and keeping tabs of time here. So as we go, we're really at a milestone. So much going on in terms of exploring space and our own planet. as we get ready to send humans back to the moon for the first time since the 1970s, and then on to Mars. I think we can do both very well. And I want you to think about this, so that we can explore other worlds by exploring our own. And again, this is key. The only way we can interpret data sent back from Mars and planets such as the moon and Titan and Pluto out there is by using the Earth as a reference. We as humans cannot go to many of these places, never will be able to. So we need to draw on the knowledge that we have from this planet in order to better interpret those planets. And it's actually, it goes both ways, because in some ways, the rock record on these planets, the landforms are better preserved on Earth. And so we can actually learn about the early history of Earth in particular that has been completely destroyed through plate tectonics and erosion. But we can learn, about landforms that we see on Mars, such as gullies, by going to the Canadian Arctic. We can test the technologies that we need. We can train. These are amazing places to train students, managers, engineers, and astronauts that we'll get to in 1 second, and to engage, keeping kids excited, interested in space. Well, if you can explore analog environments, whether in your classroom at a mock crater or up in the Canadian Arctic or in other places closer to home, and it's a great way to, again, keep everybody excited and engaged in our exploration of the Earth and of the solar system. And this is something that I've been privileged to do with a couple of other, just a shout out to a couple of other RCGS fellows who probably couldn't be here today because they've got rather busy day jobs as astronauts. But David St. Jacques on the left there, this is up at the West Clearwater Lake structure in Quebec. And Jeremy Hansen over on the right at the Horton Impact Crater. And what we've been doing is basically conducting these expeditions to the Arctic to do science, to do geology. And this actually hones the astronauts' expeditionary skills as well. These are remote, dangerous locations, not as extreme as space, but perhaps the next closest thing here on Earth. And so in the closing 2 minutes before I hand over to Tanya, I don't think there was a better way to close the talk today than sharing this iconic image of us. We're all here today on this little blue dot taken by the Cassini spacecraft near Saturn. A similar image taken by the Voyager spacecraft inspired Carl Sagan, to write his famous passage about the pale blue dot and how, as we're exploring space, it gives us a deeper appreciation of our own planet. And so with that, I will stop sharing. Thank you for your time. I don't know if we've got any questions, Lynn, but I'll hand back over to you. And then, my last slide is a segue into Tanya's talk on navigating a non-linear career path. So thank you.
Thank you so much, Gord. That was absolutely fantastic, and reached all of those elements of education and geoliteracy. I think just one question as we move to Tanya is, if people are interested in following your footsteps in this, do they come just to Western Ontario? What's the general path for them to take?
Well, actually, I might actually even pass the buck on answering that question to Tanya. And Tanya's going to talk about navigating a non-linear career path. I think one of the great, obviously, anyone's interested, please feel free to reach out to me by email or on social media. There are lots of opportunities at Western to do everything that I've been talking about, and other universities across the country too. But to me, the really neat thing about space too is that you don't actually need to be a scientist or an engineer. There are opportunities for everybody from every background, from artists to psychologists to musicians even. And so there's something in it for everybody. And so you shouldn't think that there's no room for you in the space sector and exploration of space and exploring Earth too.
Wonderful point. Thank you so much.